Okay, now we're going to look at the derivative and get information about the graph of a function from it. Okay, before we can do that, we need to understand the definition of what it means for a function to be increasing on an interval or decreasing on an interval. If you have a function and you have that x1 is smaller than x2, if the y value for x1 is smaller than the y value for x2, so that would say that f of x1 is less than f of x2 when x1 is smaller than x2. That means that the function is going to be increasing. Okay, so let's say we have x1 less than x2. If the y value for x1 is bigger than the y value for x2, so f of x1 is bigger than the y value for x2, then we know that the function is decreasing. Okay, so you're looking at the leftmost x versus the one to the right. If the y values are getting smaller as the x's are getting bigger, it's decreasing. If the y values are getting larger as the x values are increasing, then we know that the function's increasing. Okay, so now, what does a derivative tell us? Suppose you have a function continuous on an interval, and there's a derivative at every point inside that interval. If the derivative is positive for all those interior points. Now look at, if the derivative is positive, that tells me that the slope of the tangent line at that point is positive. So if I look at a function here, so looking at this graph, I know that that function's increasing. Going from left to right, the y values are rising. The y values are getting larger. Okay, so now look at every tangent line for any point on that interval. Every one of those is going to have a slope that's positive. So all the tangent lines have positive slopes when a function is increasing. So now let's say we have a graph of a function. This graph, we can see the function is decreasing because from left to right, the y values are getting smaller. Look at the tangent lines for all those points. If the function's getting smaller, the tangent lines are negative. They have negative slopes. That's representative of the function being decreasing. So what we're going to do is we're going to look at the derivative and find where the derivative is positive. If the derivative is positive, we know that the function is going to be increasing because the derivative is the slopes of the tangent lines. Or if the derivative is negative, we're going to know that the function is decreasing. Okay, so the sign, S-I-G-N, of the derivative will tell us whether a function is increasing or decreasing. This is the first derivative. Okay, so now let's see if we can sketch a function given that information. Let's suppose that a function f is continuous on its domain, which is minus infinity to infinity, and let's say we're told that the derivative is positive from minus infinity to 0, 4 to 6, and 6 to infinity. We're also told that the derivative is negative on the interval from 0 to 4. What that tells me, the derivative being negative means that the function is decreasing there, and the derivative being positive in this first one means that the function is increasing. I'm also told here that the derivative at 0 is undefined. So there is no derivative there, which could mean the tangent line could be vertical, or it could have a sharp corner at that point when x is 0. At 4 and at 6, the derivative is 0. Well, when the derivative is 0, that means we have a horizontal tangent line. Which means that we're going to have a higher or low point. Okay, so that means we're going to have either a local maximum or local minimum there. Okay, so now let's look at it. Draw your number line, label those intervals, Okay, we have the interval from minus infinity to 0. Here's 0. We have it from 4 to 6, so we're going to put a place 4 and 6 on our number line. And then we're going to look at the intervals from minus infinity to 0, from 0 to 4, from 4 to 6, and from 6 to infinity. Because our domain is everything from minus infinity to infinity. At f prime equal to, we know that the derivative f prime of 0 is undefined. So at this point, we know that we're going to have either a cusp or a corner point. So something like this or something like that, or something, similar to those. Or it could be a vertical tangent line, which is what that cusp has. Okay, so now at x equal to 4, here and here, we know we have horizontal tangent lines because the derivative is 0. Okay, so now let's see what the graph's going to look like. We start off from minus infinity to 0. Let me just kind of draw. I have no idea what the y values are. They haven't told me any y values in here. They've just told me about derivatives. So let's look at a graph, and let's just assume that that this is my x-axis down here. So let's just go ahead and assume that this is the x-axis. Okay, my y-axis then is going to be coming down here through where the y is equal to the x is equal to 0. Okay, now I have no idea where this graph starts. It might start down at negative 100. It might start at 0 or 5, whatever. I don't know. But what I do know is I know from negative infinity to 0, the function is increasing because the derivative was positive. So I know I'm going to draw that function so that it's going up. Now, I don't know how it's going up, how it's curved, but I do know it's going up. It gets to 0, and it's going to have a cusp or a corner point because the derivative doesn't exist there. So now, after that, from 0 to 4, we knew the derivative was negative, which meant that the function was decreasing. So I know it's got to come down, and I'm going to go ahead and just put a corner point there. The function is going to be coming down until it gets down to where x is equal to 4. And I know there it's going to have a horizontal tangent line. So I'm just going to have it turn around. I noticed after, between 4 and 6, it's got to have a positive derivative, so it's got to be increasing here again. So it's got to start going up again, and then it gets to 6, and I know that's where the derivative is 0 again, so it's got to have another horizontal tangent line. So I'm going to make a nice smooth corner there. And I don't know how high it goes. I don't know unless they tell me. And then it's going to be still increasing after that, so I can't have it come down. Okay, so it was increasing until it got to 6, but it's going to continue to increase. So let's keep it going upward. Okay, so my graph's going to look something like this. Notice I have a horizontal tangent line here at x equals 4. The tangent line here is also at x equals 4. It needs to be smooth there. Don't make any sharp corners. But it has a horizontal tangent line, but notice it's not a local maximum or minimum because it's still going up from there. But so just because the derivative is 0 does not mean that it's got a maximum or minimum there, local or absolute. You have to pay attention to what the derivative is doing. The derivative is still positive, so it's still going to be increasing from that point. Okay, so we have it increasing, then decreasing down to the horizontal tangent line here, then go up, has a horizontal tangent line just for a moment, and then it's going to continue to increase. So this is a possible sketch for the function. Just be sure you get all the intervals where it's increasing are correct, the intervals where it's decreasing, where it's undefined. Be sure you put the type of connection there, and then also what the slopes of the tangent lines are at 4 and at 6. So just get all that behavior correct.